Hi there, welcome to my YouTube channel. In this video, we are going to learn what is standardization of feature variable, and we will learn how to do standardization using StadardScaler of scikit-learn. So before we begin, if you have not subscribed to my channel, I request you to please do subscribe to my channel and hit the bell icon so that you do not miss anything. So let's begin. Standardization of a dataset is a common requirement for many machine learning use cases. So what StadardScaler does is it basically brings the mean of the variable of that particular feature to 0, and it brings the standard deviation of that particular variable to 1. An important point to note here is that this centering of mean and the scaling of standard deviation happens independently of each feature without having any dependency on another feature. So when you apply on one particular feature of the dataset, it is not having any effect on the other feature. So how this happens mathematically, if we see, the formula says that any particular data point or any particular value, ith root value of that numerical variable minus the mean and then dividing by the standard deviation of that feature gives us the value of the new value of that particular row of that feature. In other words, the x, that is each data point of that feature, minus mu, the mean of that particular feature, divided by standard deviation represented as s, gives us the value of that particular feature, the new standardized value. And this is nothing but this is just a z-score. And if I talk of the mean of this new feature and the standard deviation of this new feature, this becomes 0 and 1 respectively, that I already said before. And what would be the range of this? So if it is asked in an interview, then your answer should be that the range will lie between minus infinity to plus infinity, because this is nothing but the z-score and it is compressing our data in the shape of a z-table. So the z-table has a range of minus infinity to plus infinity, but if I talk empirically, if in practical scenarios, you will rarely find any value going beyond minus 3 to plus 3, and in some of the cases, some of the use cases, some people use minus 6 to plus 6 as the range. So this should be your answer. It tends to minus infinity to plus infinity, but empirically or practically it's ranging mostly between minus 3 to plus 3. So because these are the 3 times the standard deviation on either side of the mean, if you remember the Gaussian distribution, how this can be applied over there. So let's begin with a small demo so that it is clear how you can apply it and what are the nitty-gritties of it, where you find any challenges while creating your code. So I'm just creating some libraries, NumPy, Panda, Seaborn, and I'm going to take Titanic dataset, and I'm going to take only the numerical columns because StadardScaler can be applied only on the numerical columns. So I have selected these 4 columns: age, SI, BSB, Parch, and Fair. And then I'm going to slice my data and I'm going to create a new data frame with dfnum with only these 4 numerical columns. And you see the values are, some are high, some are on order of zeros and one, and some are also in a different order. So we need to scale them to apply many machine learning algorithms. So for example, you want to apply any particular linear regressor or you want to apply k-means clustering, you need to scale the data. It is always recommended. So now let's see just some float and integer data types that we have. There are some missing values, so we are going to deal with that. We are going to fill this missing value with mean age for age column. Now we have our data set which is complete without any missing values. So we know the definitions and assumptions and its nitty-gritties. So now I'm going to call the standard scaler of sklearn using from sklearn.preprocessing import StadardScaler, and I'm going to call the StadardScaler class, and then I'm going to use scale.fit and inside the parentheses I'm going to pass the complete numerical data frame. Yes, you can pass that. You can pass individual also, but when you are going to pass individual column, you need to give 2 times square bracket with the column name. Always remember, otherwise it will throw an error because it expects if you're passing only one variable as a unidimensional. Okay, I've discussed this in my another video of simple imputer. You can go and check that video. So let's continue. Then I'm going to do the transform using the scale, that is my standard scalar class instantiated, and it has already been fitted. I'm going to transform it on my complete data set. So this will give me a numpy array of 4 columns, and the shape would be the number of rows. Okay, then I'm going to convert it into the data frame again with the respective column names, and now you see that the data is scaled. Let us see what are the standard deviation. So you see the standard deviation are all equal in this case. Why these are equal? So if you check very carefully that this is nothing but these are ones, and we discussed in the definition that it will fix the standard deviation to 1. It will bring all the standard deviations for all the columns to 1, and this is what it is doing. We are witnessing it here. So this is our proof, and we can also see that mean is very minuscule. It is very small, of the order -17, -18. That means it is quite close to 0. So it is trying to bring the mean also close to 0. So this is how it is standardizing our data. So min and max can vary, but the mean and standard deviation will be of the order that we discussed, that is 0 and 1. And let's check, just for our understanding, what is the minimum of parch. Let's see what is the minimum of age. So minimum of age is -2.25. So as we see that it is going beyond -1, so it can have values beyond -1, but it is not going towards -infinity or towards a very low value. It is within -3 to +3. So this is also a kind of a proof that we get that the range would be between -3 to +3 in most of the scenarios, but theoretically the range is -infinity to +infinity. So this is all about standard scalar. So where you can apply the standard scalar, so it depends upon the data, it depends upon the scenario, because for example you might not need values between negative values, that is less than 0 values. For example, in k-means clustering you don't need values less than 0, or even you don't need values 0. So there you need to use some other kind of normalization. So it can be min-max scalar with zeros to be removed as greater than 0, and there are techniques I will explain in other video how to deal with such kind of scenarios. But that's all folks for this standard scalar in this video. I hope you guys like this video. Please don't forget to subscribe to my channel. I'll see you in the next video. Till then, see you.